All right, so welcome to this crash course on YARA, a powerful tool every security analyst should know. YARA, also known as yet another recursive acronym, it's an open source tool used for identifying and classifying malware by creating a pattern or rules. It's primarily maintained by VirusTotal. In this video, we will cover YARA basics, rule creation, practical applications, and tips to enhance malware detection. If you enjoy watching such crash course, do subscribe the channel as this boosts our confidence. Let's get started. Okay, so now let's talk about what are we going to cover in this crash course. First, introduction to YARA. Then we will learn about YARA rule structure, different components in YARA, and then we will learn to install YARA on Linux. Then we will install on Windows. Then we will write a very basic YARA rule, and then we will start with some hands-on exercises. The task one will be to identify known malware signature. Task 2 will be to detect ransomware encryption technique or maybe detecting a ransomware. Okay. Task 3 is about detecting a packed executable. And then task 4 would be to find or matching obfuscated code. Finally, conclusion. All right, so now let's talk about YARA. YARA is a very powerful tool used to detect and classify the malware by using a defined pattern or a set of rules. Okay, you create the rule yourself for against any specific malware sample. Okay, so and YARA, the full form is yet another recursive acronym or basically a rule. It's a rule-based language that is used to identify it's to use to identify a specific malware family and classify them based on a different category itself. Maybe is it a part of any ransomware family, or is it a part of any Trojan, maybe a banking Trojan? Maybe it is a part of any advanced persistent threat, or maybe it's a general malware. Okay, the purpose is performing threat hunting, malware analysis, and incident response based on what we observe by detecting a specific file signature, behavioral patterns, or maybe command and control IP address, or maybe any specific a string in the sample file. Okay. Now, next, some of the feature of YARA is basically it's simple, is flexible syntax. You don't have to learn. There's not a lot of learning curve into it, so it's very powerful, and it can scan files, it can scan memory, network traffic, everything. Okay. Now, why we use YARA for malware detection? That's a very important thing, because this is very important. It identify the malware based on known patterns. So if you have a pattern created, it can be really helpful to identify any malware category, detect the malware based on a string or behavior or IP address, anything related to that. Okay. Then threat hunting, it helps you to be proactively search for any new threats into the network. Scalability wise is also very good, because you can search thousands of file, hundreds of a file using a specific YARA rule. Okay. So there are quite a lot of use cases as well. You can detect ransomware, Trojan, obfuscated malware as well, which are hidden malware in a specific file. Maybe let's say it's a PDF file, doc file, or anything by which it is obfuscated. Okay. Now it is also used to identify command and control traffic. When your machine is getting control, when it is infected by a malware, it's actually getting control by the command and control center server managed by the hacker or threat actor. Okay. All right, so now let's learn about the YARA rule structure. Okay. YARA rules are structured using defined sections. So there are four major sections in the YARA rules. It is very important to detect any pattern in the malware sample file. Okay. Now, whenever you want to perform the detection of any malware sample and classify it, you need two things. Whenever you run the YARA command or you execute the YARA, you need your rule, and you really need the sample file. Okay, so in this video we are going to learn about how do we create a rule, or basically we are going to understand what is the structure of the rules. Okay, don't worry, we'll learn about creating the basic YARA rules in the next video. For now, let's understand the main component. The first is defining the rule itself. You start with defining the rule name at the top. Okay, it's a one liner. Next, you define the metadata like author name, description, date, and version. This is very important so that if you share with someone, he can understand what exactly it is, what's the purpose. All right. Then you define the strings. Okay, in the strings, then you specify. Let's say you want to match a specific text in the malware sample, so you can create a variable for a string. Then you can create a variable for the hex. Okay, this is basically using keywords or strings for different patterns. So this string can be used, will hold this value. This is the regular expression string, and this will consist of this specific regular expression, right? Now, finally, we have a condition. Now, condition is the one where all the magic happens. This is where if you say any one of them, so any one of them, if matches, you will see the output coming in. Okay, right? So this is where you define a pattern, maybe a plus b or a is equal to b. This is where it's define a sort of condition, and based on your condition itself, your output may vary, or your output will be decided. Okay, so based on this four category components, the final output will look like this. You can see this is a sample rule which starts with a rule name. Then you have a metadata where you have your own name, your description, date, version, reference, malware family. Then you define a string. String is a section contains a pattern, text, hex, regular expression to search for. Okay, this is where I have a string, which is a string name called malicious function. Of course, none of the malware file will have a malicious written in it, but it's just an example. Okay, this is a hex pattern which has this value. This is a known hex pattern used in most of the malware sample. Then we have a regular expression pattern to detect a sort of an email address if it is written in a specific a malware sample. And then there is a URL as well. If your malware is establishing a communication with the command and control center outside, and that might be having this specific URL, so that's what we have added in our string. Finally, the condition is any one of them. So this rule will be triggered if any one of the strings are found in the file, right? So that's where the condition becomes very, very important. And in our case, any one of them is written. All right. I hope you got it. All right, so now let's learn about installing YARA on our Linux machine. This is a Linux machine. You can say Linux, and this is its distribution, which is Ubuntu. Okay, the installation is pretty straightforward. Apt install YARA. That's it. Okay, and this might take few seconds, and it's done. Once it is done, you can verify if it has been installed properly by YARA dash dash version. You can see that means it's been installed properly. To go for a manual, you can also take help as well. The syntax format is YARA, the command, and then specify the rule name, and then just have to specify your file name or the entire directory itself. Okay. All right, so installing YARA in Windows, it's quite easier. You just visit to YARA official download page, GitHub page. And remember, this is developed, YARA is developed by the Virus Total engineer. So it's under Virus Total repository. And you can find the latest version of YARA. You can check the specific, file. You can download the Win32. Once the file has been downloaded, you will get this rar file. You can extract this file, and you will be coming under this kind of a file. Usually if it is compressed file, you should see only two files: YARA application and YARA compiler. And once you extract this file, you will be having this folder. I have two files, one sample rule and sample malware file, and a YARA rule which I created just now. So yeah, this is all you have to do. Once you have YARA available, you can just right click on the window and open the terminal from here. Once your terminal is open, you can run the YARA from here itself. uh, you can run YARA like this, and then it's all good, right? You can just run the show version or maybe help here, and you can see all the command, right? So this is all you have to do. Okay, now let's perform a very basic, let's create a very basic YARA rule. Okay, now to do that, what you need is a YARA rule and a sample file. Make sure you save both this file in the same directory where your YARA compiler and YARA application is stored. Okay, now I'll show you my YARA rule, and it's very simple. This is the YARA rules, but what is the sample? This is my malware sample file, right? And it contains just text. And what is the text? This is a test malware file with no malware in it, right? So this is my malware file. Now it doesn't look like a malware, it's just a text, but my YARA rule is also very simple. You can see this is my name of my YARA rule. Then I have a string in it. Now I have first string which says I want to look for any string with word malicious, right? Currently I don't have anything as malicious, so I'll use this malicious with no malicious. So I'll say with no malicious intent, maybe. Okay, and let's save this file. And the condition is simply this string name itself. That means I just want to look for this malicious, sorry, this the string in the file, right? And which is malicious at the end. I hope this was clear. Now let's save this file. Let's save this file too, and let's come here on the command line on the terminal. So what you can do, you can just right click on this folder and just click on open in terminal. You will see here, you will see this. Okay, now let's run the YARA application. So you will say dot YARA slash YARA, and then you have to first mention the rule name, and that's rule.yar. Remember, the rule name for YARA is .yar. That's the extension, right? Next, you have to define the rule name. So that's rule.yar.txt is the extension. And then you specify the sample file name. So I'll say sample file name. So sample file name has been mentioned as well. If it is valid, if I see the desired string in the sample file, I should get the output. Perfect. Can you see that this is the example rule and I see the output, right? But let's do one thing. Let's remove this malicious no intent. Okay, let's just say no intent. Let's save this file and let's run it again. Let's see if we see any output. We don't see anything. Can you see this? Let me increase it. Okay, I don't see anything, right? Let's do it again and you should see something, right? So if we do this malicious again, malicious, save this file, come back, run it, you see the output, right? So that's one of the very simple YARA rules. All right, so let's begin with our very first task, which is identifying the known malware signature. So this is going to be a very simple YARA rule, okay? And I have created a directory for every task. So you can see for task 1, we have a directory, task 2, task 3, task 4, task 5, okay? Under each file, I have then YARA rule, the YARA rule, and a sample file. Okay, it's a randomly created sample file. Okay, I'll share you, don't worry about it, I'll share you the GitHub link for the same. Okay, so let me show you the rule first, then I'll show you the sample file. Okay, you can see the rule is task1.yar. Okay, in this, the rule says it's about known malware signature. So let's say I have a string created, okay, which has which is a, right? So that's my string which holds the value this. Now this is basically an assembly, it's a set of assembly instruction commonly used in the malware, especially in the scenarios involving API calls for memory allocation. So whenever you malware get installed in the machine, it has some purpose, right? So it might it might look for might involve in some API calls for memory allocation for it to work, or manipulation as well, right? So every block represents some value. For example, 6A40 represent push operation. Okay, so this holds certain value and this performs certain activity. For example, 68 till 00, this one indicates push operation. So this will actually push the value of certain value. I guess this is 3000 in the hex value on the stack, which can represent a memory allocation size and allocation flag as well. This is usually in the Windows API call. Okay, which talks about the virtual allocation function. Okay, so we will not go much detail for now. Just understand, if you have a known pattern, it could be anything. It could be even a text. Maybe it can be a text like simply you are hacked, for example. So this can also be your variable. For example, I can even add something like this. Let me show you that. Right, so I can even have a string which can be B. Okay, and then I can say, let's say, you are hacked. Okay, now the point is, this should be present in my file, right? Because in this case, the condition said, the condition says the A should match. Okay, uh, if this doesn't present in my file, I won't get the output. Let me show you something. Okay, now let me look at my actual file, which is file, the sample file. In this is a sample file. Okay, randomly created file. Somewhere in the file, I have that value, this assembly operation. You can see this embedded malicious sequence. Okay, so you can see this value here. So if I want to run this operation, I can just simply type YARA, then yeah, my YARA rule, which is task 1 YAR, then file.text. Okay, you see some problem here. The known malware signature, the various string B is not been called anywhere, right? So that's a problem. What I can do is I can go to YARA again, and I can just say maybe any of them. Okay, so any of them should be work. Okay, if A is there, it would work. If B is there, it will work. So it will give me some output. Okay, in either case. So let me run it again. Perfect, I can see the output here, right? Because it matches the first parameter, which is my embedded value, assembly instruction. Now, how do we verify? Basically, you can also verify which parameter or which string was matched. So you can run -s, and you can see here, right? The string A was matched, and this is the matched criteria. Now, if I want to modify it a little, what I can do is, let's say I want to modify my actual file, right? So I can add you are hacked into it, right? So let's go to the sample file, and somewhere in the sample file, I can say you are hacked. Okay, it's that simple. Sorry, something happened. Okay, you are hacked. Okay, so I've written this text. Let's come out now. Let's run it. Okay, but for this to work, I mean, remember the rule first. Let's look at the rule. I have both the string available in the sample file, which is file.text, right? txt. Now let's look at the YARA rule one more time. Okay, sorry, what did I do? Okay, sorry. Yeah, perfect. So I have this as a condition which is already present in the file, and the another one which is you are hacked, and I have a condition saying any of them, right? What if it is all of them? In that condition, both should be present, right? Then only it will work. Otherwise, it will not. Okay. So let's say I run this file again, and let's see. Perfect. Can you see this? Both the condition got matched here, right? What if I change it to all of them? Basically, both of them should match. Sorry, what I'm doing. Give me 1 second. All of them. Okay, and let's come out. What do you think? What would happen? Basically, I should get the output because both of them exist, right? So I'm getting the output. What if I remove your hacked, right? Let's go to the sample file, and let's remove this you are hacked, and let's keep the condition you are all of them, which is basically an AND operation, which says that both of them should be there, right? So all of them means both of them should be there, then only the condition will match, and then only it will show us the output, right? Let's see if this works now. Can you see this? It didn't work because I have and operation. That means both A and B should be there, then only I can see the output, right? So that's all about identifying the known malware signature, and you can actually play with any text, any string in that. All right, so this in this task, which is task 2, we are going to detect ransomware by using YARA rule. Okay, ransomware is a kind of a malware which once installed in our machine or maybe delivered in our machine through phishing attack, it encrypt all of our files, and to get access to our file back, we need to enter a key, and this key can only be shared by the hacker, and they ask you for a ransom amount in exchange of that. Okay, so let's talk about how exactly the YARA rule and the sample file looks like in this case. So I think the purpose is very very clear: to identify ransomware techniques, especially the encryption routines in the memory. And so let's understand quickly. Go to task 2 folder. Okay, and let me show you the task 2 YARA rule. Okay, so this is the YARA rule we need to look at. So the rule name is ransomware encryption. We have two strings, encrypt 1 and encrypt 2. So this is a specific string, which our YARA rule will look into, and the condition is to match all of them. That means both the strings should be available, then only the condition will be fulfilled. Okay, so, and now let's come out and let me show you the sample file, which is file to text, right? So I guess it's here, and another one, I think it's here, right? Let's run the script. Let's run the YARA rule and file text. It works, right? When it is successful, you can see the rule name, YARA rule name, and the sample file against that, right? To see which string got matched, so you can enter, sorry, -s. Perfect, you can see both these string got matched, right? Now it's happened twice, I guess, so that's why you see two times, right? Now let me show you one more file here. I have one more file which is more of a real world ransomware. Okay, it's a ransomware SDD cryptor. Okay, hard disk cryptor ransomware. So if I show you this ransomware file, let me minimize this a little. Yeah, so in this is the rule name, and this is the metadata, which has the description reference from Trend Micro. Author name, it's his Twitter account, I mean the X account probably. And this is the string. This has two component: unique string and generic string. In the unique string, it looks for you are hacked, because you see when your ransomware get executed, I mean the hackers ransomware get executed, you see a banner saying that you have been hacked or you are hacked. Now all of your files are encrypted. To get your file back, you have to pay some ransom amount, and we'll give you the key, and this key can you can use this key to get the file back, right? And now these are all the messages, right? They might be sharing their email address or maybe their Bitcoin key. They don't usually share their email address, but they might share their Bitcoin address and everything, right? So these are some of those address, right? Your hard disk is currently securely encrypted, ASCII wide, and these are generic string. Wipe all the password, descriptor, some ASCII wide information, file information as well. Now the condition is very interesting. This says at least two of the uh, means unique string should match, or four of the generic string should match. You see this dollar sign, then G, and then asterisk. This is the wildcard entry. So this can be 1, 2, 3, 4, 5, 6, anything. So this simply says at least two of this unique string should match, and or maybe four of this generic string should match. Then only the condition will be fulfilled, and we will see the output, right? So yeah, that's the real world YARA rule I wanted to show you. I hope this was clear for you. All right, so task number three, it's about detecting packed executable. So before we even detect, we need to understand what is packed executable, right? So basically a file. It's basically a file which is compressed or encrypted using packing algorithm. Maybe most popular is UPX. Okay, so by doing this, we basically, what happen is, let's say you have a malware sample. So what hacker basically do is they basically use a sort of an algorithm. Okay, this is packing algorithm. By this, they actually compress the file and encrypt it, or maybe encrypt it, and then make it a brand new file. Okay, now this file, this way your actual malware get hidden from any static analysis or maybe antivirus as well. So it become quite undetectable sample, right? So packed executable typically include a unpacking routine. Once it is in the runtime, it start unpacking itself. So once the executable is launched, the decryption or decompression basically start happening. It's The code, it's get executed in the memory for execution. The process involves multiple API call as well. This decryption process involves multiple API calls, and this is what we are going to utilize for detecting our packed executable. All right, so now let's move to the task three. And under task three, we have our YARA rule, which is task three YAR, and our sample file, which is file three text. Okay, now let's look at the YARA rule first, which is this. Okay, you can see it's a bit advanced. Yeah, you can see this. This is the unpacked sequence. When your compressed file get unpacked, it will launch multiple API calls, as I said earlier, and there would be multiple unpacked sequence will happen, right? This consists of this is where the registers are saved and the memory address are loaded. Okay, so every operation has some sort of a command or sequence of command. Okay, so this, if for example, this basically represent the unpacking routine. Okay, where the registers will be saved. Okay, and this specific sequence, if you look at it, this basically set up a stack frame which basically starts the function memory layout. It is often used in the packed executable to prepare a space for decrypted code. Now this is the sort of a function decrypt, and this is the virtual allocation. So these are all basically API calls. These are all API calls which are used during the unpacking to allocate memory, like virtual allocation. You can see virtual allocation, or write unpacked code to the memory, or maybe adjust any sort of thread execution as well. Okay, so these all function, or the word API calls are very very important. I have also added of an IP address as well that should match. Okay, now in the condition, I've made it very flexible. I just said any of them. Okay, to make it more complex, or if you are 100% sure that there won't be any false positive, you can just do all of them, right? In our case, it will match any of this string, and the condition will be fulfilled, right? So let's come out. Let me show you the sample as well quickly. You can see the file. So this is our file. Okay, now let's run it quickly. Yara task 3 file 3. Perfect, it worked, right? Let's see what was matched. So you can see -s. Perfect, you can see these are the string which were matched. Perfect. So this is task 3 for detecting packed executable. All right, so task number 4, it's matching or detecting any obfuscated code. Now, obfuscated code is basically a code that has been intentionally changed or modified to make it hard to read or to understand for any security analyst or maybe malware analyst. Okay, this is usually done by maybe renaming any sort of variables, or maybe removing any unwanted white space, or removing any white space. Okay, or maybe adding any redundant operations or duplicate functions, which is not so important. Okay, so but it is different from packing. Okay, it is different from packed executable or packing operation, because obfuscated usually does not involve any encryption or compression techniques. Okay, so to do this operation, basically obfuscated code remain in its in modified state at the runtime. Okay, and it is not unpacked or decrypted, but it may rely on a complex logic on which makes it hard for any malware analyst to perform any reverse engineering, or even it is difficult for some analysis tools as well, right? Now let's go to the task 4. Okay, and under this we have this YARA rule and sample file as well. Let me show you the YARA rule first. Okay, so the YARA rule consists of this. Okay, again we have a 4 string here, and first says about the anti debug pattern. Usually whenever we obfuscate the code, or I mean the hackers or malware author obfuscate the code, they add some debug anti debug pattern, so that it becomes difficult for any malware analyst or any reverse engineer to debug it, right? So that's where we can add some anti debug pattern. Now this can be helpful for us to find out any obfuscated code. There are some API calls as well, which we have added, or encoded string as well, like hidden data, right? And the condition is any of them. And I'll also quickly show you the file. This is the entire file. Okay, now let's run the YARA rule. Task 4 and the file. Perfect, there's a match. Let's look what has been matched. Perfect. So we have two variables being matched, which is API virtual allocation and encoded string hidden data, right? So this is how we can create a YARA rule for detecting any obfuscated code. All right, so I hope you got good confidence about YARA rules. I'll be sharing you the link of each exercise in the link in the description section. And if you enjoyed watching this video, please hit the like button. Thank you so much for watching.